This is part 2 of the video lecture for Math 181 for Friday, April 24th. And in part 2, we're talking about finding areas enclosed by curves. And in part 2, we're going to do 2 more example problems. The first problem is calculating the area between the 2 curves f of x equals square root of x and f of x equals x squared. As I said before, a good idea here is to first make a rough graph of these 2 functions. So let's do that. Okay, the square root function looks something like this. It's a function that has a gradually decreasing slope. And then f of x equals x squared is a parabola with an increasing slope. Okay, so it's clear from this graph that these 2 curves intersect at 2 points, and this means that these 2 curves enclose a certain amount of area. So we want to find what is the area enclosed between these 2 curves. Okay. Let me label these 2 curves again. This is f of x equals x squared. This is f of x equals square root. Well, here we're not given an interval over which we're interested in calculating the area. We actually have to figure out what is this interval. So in other words, this is our interval here. This is point B, and this is point A right here. But we need to figure out A and B. We're not given A and B. So in other words, we need to figure out the points of intersection of these 2 curves. How do we do that? The way we do it is at these 2 points of intersection, these 2 curves have the same y value. So what we do to find this is we set square root of x equal to x squared. Okay. And we solve this equation. To solve it, we square both sides. If we square both sides, we get x equals x to the 4th. And then what I'm going to do is subtract x from both sides. So I get x to the 4th minus x equals 0. And then what I can do is I can factor this equation. Okay? And if I do that, I get x times x cubed minus 1 equals 0. So this equation is giving us the solutions, the points of intersection of these 2 curves. And what are the solutions to this? Well, one solution is x equals 0, and the other solution is x equals 1. So these 2 curves intersect these 2 points. Now we know A and B. A is 0. We already knew that because we're starting at the origin, but now we know point B is 1. So now we have our interval of integration. And to calculate the area, we're going to integrate from 0 to 1 of our upper function, which is square root of x, minus our lower function over this interval, which is x squared, dx. Okay, and now we integrate these. This is a standard integration. Square root of x is x to the 1/2. So if we integrate that, we get x to the 3/2 over 3/2. If we integrate x squared, we get x cubed over 3. And now we're evaluating this integral from 0 to 1. Okay, and this simplifies to 2/3 x to the 3/2 minus x cubed over 3, evaluated from 0 to 1. Now we can plug in our limits, and we get 2/3 times, now plug in 1 to the 3/2 power is 1, okay, minus x cubed over 3 minus 1/3, right? And now we subtract off the, now we plug in 0 for x, and we get a 0. So this is really 2/3 minus 1/3, which equals 1/3. So that is the enclosed area between these 2 curves. Let's consider a third example problem, just so we get some good practice at this. So let me erase this. Okay, in our third example, we're interested in calculating the area between the 2 curves. Here's our friend square root of x again, and f of x equals 1 over x, and the line x equals 4. So here we have three boundaries. We're interested in calculating the area between or enclosed. I really should use the word enclosed, so that would be a better word. F of x equals square root of x, f of x equals 1 over x, and x equals 4. Again, let's make a simple graph of these functions. Okay, well, square root of x, we know what that looks like. It's a function that looks like this. 1 over x is an inverse function, so it drops with x like this. Okay. And finally, the line x equals 4 is simply a vertical line located at x equals 4, like this. And so the area we're interested, the area enclosed by these three curves / lines is this area right here. So we're interested in calculating that area. Now, we need to do that, we need to find the point of intersection right here. What is this point A? So we need to find the point of intersection. Okay, and again, the way we do that is we set these two curves, this is the point where these two curves intersect. We set these two curves equal to each other. So we set square root of x equal to 1 over x. If we multiply both sides by x, we get x to the 3 halves, because x divided by x is 1. X times x to the 1 half is x to the 3 halves. So we get x to the 3 halves equals 1. This has a solution. This only occurs where x equals 1. So now I know my point A here is 1. So now I know my limits of integration, and I can calculate the area enclosed by these curves. The area will be the integral from 1 to 4 of the upper curve, which is square root of x, minus the lower curve, which is 1 over x, times dx. Now we can perform these integrals. These are simple. Okay, square root of x, we just did that. That's actually 2/3 x to the 3 halves. We know that. What is the integral of 1 over x? Well, that's natural log of x. So we get natural log of x. And our limits of integration are 1 to 4. Okay. Now we need to plug in these limits. So we get 2/3 times 4 to the 3 halves minus the natural log of 4. And then we plug in the lower limit. We get 2/3 times 1 to the 3 halves minus the natural log of 1. Okay, let's simplify this. The area is 4 to the 3 halves. How do we do this? Well, we take the square root of 4 and get 2. And then we cube that, we get 8. So this is like 2/3 times 8. This is the natural log of 4. Okay, 1 to the 3 halves is just 1, so we get minus 2/3. And natural log of 1 is 0, so that goes away. So in other words, this equals 16/3 minus 2/3 minus natural log of 4. Well, this equals 14/3 minus natural log of 4. And if you guys plug this in your calculator, you should get 3.28. And this is now the area enclosed between these two curves. So this concludes our video lecture, part 2 of our video lecture, with a couple examples. I will see you guys on Friday.